In example Donia, loads are computed in volt amps because this is how the demand factors are tabulated. By multiplying the volt amps of each load by the corresponding demand factor, we obtain the contribution of each load to the total service load. In example done. B. The loads are computed in amps because the demand factors are already included in the amp rating of the individual circuits. If this were all one problem, begin by computing the volt amps of each load using the demand factors in done. Then add the volt amp values to obtain the total service load in volt amps. Article 220.22 requires the neutral conductor to be sized for the maximum imbalance between the neutral and any one ungrounded conductor. In done. The neutral load is calculated by summing the current and the neutral of all loads in the same phase. This ensures that the neutral is sized to handle the potential unbalanced load. In done. The neutral load is not calculated as the maximum imbalance. Instead, the loads are balanced between phases, which is not compliant with Article 220.22. Section 430.24 requires that air conditioner and heat pump loads be increased by 125% when calculating the service load. This is because these loads can contribute to the peak demand on the service. If a house has central air conditioning, add 125% of the condenser load to the service load calculation. If a house has both electric heat and air conditioning, add 125% of the larger load to the service load calculation. To correctly perform a service load calculation, consider a 1500 square foot house with laundry and small appliance circuits. After applying demand factors, these circuits contribute 5,100 volt amps to both the service and neutral loads. A 12 kilovolt amps range adds 8,000 volt amps to the service load and 5,600 volt amps to the neutral load. A 5.5 kilovolt amps dryer contributes 5,500 volt amps to the service load and 3,850 volt amps to the neutral load. A 6 amps 230 volts air conditioning unit adds 1380 volt amps to the service load but nothing to the neutral load. A 12 amps 115 volts air conditioning unit adds 1380 volt amps to both the service and neutral loads. An 8 amps 115 volts disposal adds 920 volt amps to both the service and neutral loads. A 10 amps 120 volts dishwasher adds 1200 volt amps to both the service and neutral loads. Central air conditioning drawing 6440 volt amps adds 125% of that value, which is 8050 volt amps, to both the service and neutral loads. The total volt amps for the service load is 31,530 volt amps, which equals 131.5 amps. The total volt amps for the neutral load is 26,000 volt amps. To calculate the neutral load, find the maximum unbalance. Consider the 115 volts loads. These include the 12 amps air conditioning unit, the 8 amps disposal, the 10 amps dishwasher, and the 8050 volt amp central air conditioning load divided by 120 volts, which equals 108.3 amps. Therefore, the service load would be 31,530 volt amps, which equals 131.5 amps, with a neutral load of 108.3 amps.